Back in 2010, I interviewed a range of people who were involved in what was called Beacon Northeast. This was a coordinating unit for public engagement for universities and communities in the northeast of England, where I was working at the time. I was interested in what different people involved in the Beacon were doing, but also how they framed and talked about their activities. And this is what one science communicator told me when I interviewed him. He said, "I regard myself as a professional science communicator, so I feel like I've seen the development of what started out as public understanding of science. Science communication was created in parallel with it as the professional discipline that delivered public understanding of science, and then realized not only was that an incredibly condescending approach, but actually it was wrong. It just didn't work. It wasn't accurately describing what was going on. Then there was the period when it was public engagement with science and technology, dialogue. There's things like co-inquiry, terms like that coming up now." So this is what he told me in 2010. And I mention this because in many ways the recent history of science communication is a history of language, of different terms. As this communicator told me, there's been public understanding of science, science communication, public engagement with science and technology, dialogue and co-inquiry, just to mention a few. This probably seems confusing, and in Beacon Northeast, where this communicator worked, it did cause some issues. People might be talking about the same kinds of activities using different terms, or the other way around, talking about different things but using the same terms. It's a useful way, this quote, of introducing my content today, because these different terms often suggest different relations between science and public audiences. They come from particular experiences of how science communication is received. At the heart of this is the idea of public resistance, which you've already heard about from Martin Bauer. Public resistance, or controversy, has been the sparking point for developing methods of science communication that move from emphasizing public understanding of science to those that focus on public engagement or dialogue. The UK is a particularly good example of this because, as the Beacon communicator said, there's been a fairly strong shift in what kind of science communication is emphasized and promoted. So, in thinking about this, it's useful to go back to the 1980s. In the UK, this was a period when science communication really became prominent. Scientists were encouraged to do it, and there was lots of funding available to help them do so. The language here was of public understanding of science, PUS, and the emphasis was exactly on telling lay people about science. Science communication aimed to increase public knowledge of scientific facts and thereby to enhance public appreciation of science. The idea was that to know science is to love it. So this is where our communicator says that PUS, public understanding of science, was an incredibly condescending approach, to quote him. This argument, which arose from the studies of science communication that was going on, was that it was actually very arrogant for scientists and science communicators to attempt just to push scientific facts down public throats. What if their audiences also had relevant knowledge or opinions or views about the science? Shouldn't they also have the opportunity to talk back to scientists? There was a famous case study which looked at the interactions between government scientists and sheep farmers in the aftermath of the Chernobyl explosion, which caused some radioactive fallout in the UK. This case study showed that all too often the scientists simply refused to listen to the sheep farmers or to take into account the expertise they might have in things like how the sheep grazed, how rainfall might affect agriculture. So this was a key case, a very well-known case, of how science needed to pay attention to lay views and experiences. At the same time as these criticisms were emerging, there were a number of very high-profile public controversies around science, including over British beef and Creutzfeldt-Jakob's disease, CJD, foot and mouth disease, and the development of genetically modified crops. As Martin Bauer discusses in his book, these were moments where the wider public resisted particular technological developments and the way in which they were being managed by scientists and the government. And again, to go back to what our communicator quoted at the beginning has to say, these were also moments when it became apparent that the PUS, the public understanding approach to science communication, just didn't work. In other words, resolving controversies is not aided by scientists or the media simply repeating the facts as they see them. Just telling people about science is not an effective way to deal with public concerns. Instead, you need to acknowledge whatever it is that they're concerned with and try and work out a solution together. It was in these ways that UK policy on science communication began to emphasise more and more ways of engaging the public that were dialogic, participatory and interactive. This might mean a science event or a discussion rather than a public lecture, or scientists doing more forms of communication that were face-to-face with members of the public rather than just talking to the media, so having their words mediated through somebody else. But it also meant that lay people were given more opportunities to contribute to scientific priority setting and to the scientific process itself. So, for instance, many medical research charities now actively involve patients, who are the ultimate users of the research that they fund, in their funding decisions. Similarly, government research councils have used public consultations to help them prioritise which aspects of applied research that is close to market, should be funded. Most recently, there's been the rise of what is called citizen science, where non-scientists can get involved in research projects by gathering or analysing data. What does all this mean for us as science communicators? I think first it helps us remember how wide the range of forms of science communication is. In this course, we're focusing a lot on science writing and storytelling and on video and audio, and these are all extremely significant forms, ways in which science is communicated to the public. But we should also keep in mind that science communication might also take the form of a dialogue event in a pub, or a science festival, or a piece of science theatre, or a government consultation. These formats are also important, and in some cases, they might be more appropriate ways of allowing the public to engage with scientific knowledge. The second thing that this history helps us to keep in mind is our audience, how we're treating them, and what they might have to say about the content that we communicate. Science journalist Tim Radford tells writers that the classic error in journalism is to overestimate what the reader knows and underestimate the reader's intelligence. Lay people are not stupid, even when they don't know a lot about science. If they have concerns about a particular aspect of science, it's useful to understand where those concerns come from. In the case of genetically modified organisms, for instance, research has shown that publics are often worried not so much about the science itself as questions such as who owns it, who benefits from it, and what impacts it might have on biodiversity, the environment, and the food chain. Exactly as Martin Bauer argues, we can take public controversy and concern not as a problem, but as an opportunity for debate, so that science and society can work together to develop socially robust innovations. What are some of the ways that this can be done? There are a range of ways in which scientists, policymakers and lay people can debate particular issues together, ranging from the very informal to the structured and formal. Dialogue might happen in the comments underneath a blog post, at a science cafe, or as a university holds an open day. but it can also take place through organised, deliberative and participatory processes. These can take several days and involve a representative group of lay people who are tasked with deliberating a particular issue and making a recommendation on it. They can ask a panel of experts any questions that they have, but the emphasis is on their views and values and on building a consensus. In Denmark, the Danish Board of Technology has a long history of using these kinds of methods to enable public participation in science, but also in using them in government more generally. Key techniques include the consensus conference and the citizens' jury. To conclude this module, you will investigate these techniques a little further by exploring some case studies of public participation in science. I'm going to tell you the names of some relatively well-known cases where lay people have been invited to deliberate on science. Your task is to research these and to gather as much material on them as you can. You might want to look out of formal reports that came out of them, academic writing about them, web pages, blogs, news coverage, images or video. In essence, your task is to make yourself familiar with these case studies and, most importantly, to decide what you think about them. Is this a good way of doing science communication? Can we, as communicators, learn anything from them? How could they be done better? So your case studies are the Worldwide Views Project, the Café Scientifique movement, NASA's Asteroid Initiative Citizen Forum, and the Nano Jury. There'll be a Slack channel available for each of these where you can put your material. You can focus on one in particular or split your time between them. Do try and find as much material as possible, and again, most importantly, discuss them with your colleagues and try and reach an assessment of them. Good luck, have fun.